Alright, so our next topic in this is the good old-fashioned channel. And people call it C-channel and that kind of thing, but it's actually not necessarily just C-channel. There's actually two different types. But this cross-section looks like this. This is a steel member that is shaped like a C, obviously. Draw a little sketch of it here, little break line. And it can be used for a variety of things. You actually see it a lot on trailers. It's a great component for trailer construction. They can also be beams. They can also be parts of staircases to kind of seal in. One of the advantages of the C shape is that on one side you've got this nice flat face. On the other side you have the ability to kind of like tuck things in and shape around or have a little gap to work in. Again, you'll notice that beams like this are also stressed in the same way. This is where the stress will be if it's actually spanning over a distance, like so. So the stress, again, is always in the top flanges, not always, but in most bending cases, the stress critical areas are right in the top, so therefore there's material up here and down here, and a thin web in the middle. This is still called the flange. They do call it like a toe flange, but it's still just the flange. This is still called the web. And of course, your flange width is this value here. Only problem is, again, like W-beams, this is not given to you in a call-out. What's given to you in a call-out is the overall component. So let's take a look. Here we go. This is a channel. This is your typical call-out. If I can get my controller to work here, there we go. This is your typical call out, a C10 by 30. And this, of course, is the depth. So this, for example, if this was the C10, it would be 10 units tall or 10 inches tall. And then the 30, of course, would be 30 pounds per foot of beam. Again, the flange, and the web. And you'll notice there's two different types of channels. There is a C channel and an MC channel. A C channel and an MC channel are still C-shaped, but you will find that if you actually look at a diagram of them, the MC is shaped a little bit differently and got a little bit different thicknesses. So just because someone says a C channel doesn't actually mean it's actually going to be a C channel. It could be an MC, 10 by 30, if you will. So keep that in mind. MCs for that. So they'll be called out the same way as they will be on other plans, though. Like if it's set up as a beam, then it's going to be laid out the same, and they're just going to say, all right, so like if here's a column, and here's a column, maybe a center line, and it's going to be called out as a MC 10 by 30, or it could be C10 by 30. Well, let's say it's a C12. I don't know. Who knows what they're going to be. But all this stuff is available for you. Now, by the way, the group that actually establishes some of the key components of this is the ASTM, the American Society for Testing and Manufacturing. So what they're actually doing, they actually control a lot of the ways that a lot of the steel stuff gets made. So for example, since a steel component may be used in a building, the quality control is super critical. Like they may get the shape right, but if the material composition isn't right, that means that the beam isn't as strong as it's supposed to be on paper, which means engineers like myself can't actually design with it correctly. Or we design with it, turns around, if we get like a bad beam, something can collapse. So it's really critical that when beams and structural steel are made, they're made to the ASTM standards. Like for example, one of the common values of steel strength that we have is 50 KSI. We also have 36 KSI, which means that it is an improved steel strength, which stands for 36,000 PSI capability. Now, most structural steel that you're using in buildings is going to be in the 50 KSI range, sometimes 60. Just kind of depends on the type of material. 36 KSI steel is not used that much anymore for structural work, just because we can't really, people like the 50 strength more than they do this 36. So ASTM establishes the standards for manufacturing of the making of these beams. And another group that you can check out is AISC, and you can Google these terms for yourself. These are institutes and groups that basically create standards. Now, I actually have some AISC manuals that I use for my structural design stuff, simply because they have nice graphics and those kind of things. So If you get into steel fabrication, you might be using manuals provided by AISC, but you're going to be buying steel that meets ASTM standards. Okay? Hopefully that makes some sense there. But as far as the C channel goes, nothing really special about it. You're just going to buy it, use it, and weld to it as need be. And you're going to probably have to look up the dimensions associated with each individual size. Now, like I said, the call out's pretty simple. No problems there. While we're here, we'll go ahead and talk about another one though. That is the T-beam, or the T. We'll skip the angle and do it on a different lesson. The T is also sometimes used as a beam. You'll notice that its call out, you don't see this as much, to be honest with you, on steel fabrication. You see it, but you just don't see it nearly as much as you see C channels, angles, and W beams. For its call out, you might see a T. You'll notice that they actually provide the flange width, which is the distance from here to here, the depth, which is here to here, and of course the stem thickness, this right here. This is one of the few times that you'll see a call out that includes that much pertinent information. Notice that there is no weight per foot in this case. T's are typically smaller, they don't get that large, and they have a specialty in design being used for certain things like, catching concrete slabs or steel deck fabrication. They're an interesting cross-section that we can use for a variety of special cases. But like I said, you don't see them that much. But again, the overall part just looks like a T. Now, whether it's upside down or like you see it here, who knows, but it'll just be called out with this T value right here. Sometimes designers will actually use the TEE before they call out the numbers, but technically it should just have a T in front of it. All right. So that's your MC shapes, or your C, your channels, and your T's. A little bit about ASTM and some of their standards. The good thing is, even if you don't remember the material from this lecture, you can always do a quick internet search, find cross-section shapes, sizes, terminology, and dimensions in like no time. So, it's handy to keep those reference materials around, but you can also find it on your smart device pretty quickly. Okay? We'll see.